All right, in this video, we're going to be doing page 5 of note 7 of Calc D. We're going to be talking about double integrals over regions that are not rectangles. So some of the bounds are going to be functions. Maybe the bounds for x will be functions, maybe for y. When they get more complicated, sometimes x and y will have those sorts of bounds, and then you got to be really clever about how you break up the region. But we're not there yet. So let's take a look at what we mean. So the first integral you can see is from a to b, and that's a dx. So the x bounds are vertical lines. And then g of x to f of x. So those are just going to be functions of x. So y is varying. And then we have our integrand. So let's draw it. So we have this. This is the xy plane, right? So I'm going to start off. I know that y is going from g of x to f of x. So I'm just going to put like an upper function, call it f, and a lower function and call it g. And there you go. That's like the whole idea, right? And then our x bounds are constant. So we'll have a and b. And our region kind of fills in like this. So this feels very much like a Calc 1 region to me, right? Like in my mind, this is like the normal Calc 1 region where I would integrate from a to b, top take away bottom, f of x minus g of x. That's essentially what we do. You look at the region, you kind of in your mind set it up like a Calc 1, Calc AB type of integral. So what's happening is x is always going to want to go from left to right. Sometimes the bounds will be constants, which means that dx will be the last thing you deal with. Sometimes they'll be functions, which means you'll deal with it first. And then y always wants to go from bottom to top. Sometimes the y bounds will be functions, in which case you deal with them first, or they will be constants, in which case you deal with them last, which we'll look at in a second. But that's like the whole idea. So this is very similar to what you've done before in terms of setting them up. So our next integral is from c to d for y, so those are horizontal lines, and then g of y to f of y, so those are functions of y. So x is a function of y, so those are going to be those weird little curves that you draw. They're like vertical curves, I guess, in my mind. So I'm going to sketch this again. So we have xy. Now we know that we're going from g of y to f of y, so that's from left to right because x always wants to go from left to right. And then our y bounds are going to be from c to d, and y always wants to go from bottom to top. So here's our region. And as I said, y, and this again is like what you encountered in Calc 1, where if you had to set up something dy, like in terms of y, you would be integrating from bottom to top, so from c to d, and then you have to do right take away left, f of y minus g of y. How do you end up with that? By the fundamental theorem, you make f the upper bound and you make g the lower bound, and it will work out for you. So we're going from left to right, and we're going from bottom to top. That's always how these things want to work, and you just have to keep that in mind. So we get this. All right, so a couple of things to keep in mind here. First one is that, as I mentioned, x wants to go from left to right, y wants to go from bottom to top. You might remember in like Calc 1, if that's not happening, you switch the bounds and change the sign. Same thing could still apply here. And then you can look at both of these regions, and if this was not a video about multivariable calculus, and someone said set up integrals for these areas, what you would set up in Calc 1 for this one would be the integral from a to b of top take away bottom. How do you get top take away bottom? Using the fundamental theorem. The top curve is the upper bound and the bottom curve is the lower bound. And if you compare that to the integral above, you can see that that's what happened. Same thing over here. I won't make you watch me write it, but we would have done the integral from c to d of right take away left, so f of y minus g of y. And again, how do you get f of y minus g of y? You make f the upper bound and you make g the lower bound. Translates really nicely. All right, so what I'm going to do now, we're just going to sketch the region over which you're integrating. So we're not actually going to do an integral, so this will be a lot shorter. And also, I had a lot of trouble graphing these by hand, so I'm just going to use GeoGebra to like put in some pictures. But let's see what we're going to look at. So for a, we're going from 2 to 3, and then from 3 minus x to 2 plus x of f of xy, dy dx. Okay, so the key here is looking at the bounds and realizing that they represent inequalities. So because it's 2 to 3 dx, x is going to be between 2 and 3. So that's one set of inequalities. Those are vertical lines. We know that we're stuck between the vertical line at 2 and 3. Somewhere between there is our region. Where is our region? Well, it's going to be between these y bounds. So y is going from 3 minus x to 2 plus x. So we can write this down. And what you end up doing when you graph it by hand is you just graph y is equal to 3 minus x, y is equal to 2 plus x, and then you only care about it between 2 and 3. So here is the image that I created. That's our region. It's shaded in. Pretty good. Let's look at the next one. So the next one is weirder maybe, but it's a scenario that you'll encounter sometimes. So we are going from -4 to 1, and then y squared to 4 minus y. So dx is the inner and dy is the outer differential. So we have horizontal constants, and then we have, I feel like, did I talk about horizontally and vertically simple regions? I don't remember. Let me finish this and then I'll talk about it like kind of briefly. Even though this one's a little less simple. So here's our bounds. X is going to be between y squared and 4 minus y. And then y is going to be between -4 and 1. So I've used GeoGebra to sketch this. This one's a little weird. Okay, so let me talk briefly about horizontally and vertically simple regions. Vertically simple regions are the Calc 1, Calc AB normal regions. You're integrating with respect to x. You're doing that because the top curve and the bottom curve don't change or whatever. This region on the left here in the picture that we drew for part A is a vertically simple region. In the entire region, you could take a vertical line, pass it through, the top and bottom curves will never change. Now on the right-hand side, if you try to take a vertical line and pass it through these shaded regions, what are you even doing? This is a very complicated region, right? So you would not want to do that. This is actually a complicated horizontally simple region by itself. Never mind trying to do this with vertical, because you have to actually do two things. So you'll need two double integrals for this, because on the interval between -4 and 1, the right and left curves switch. So you're going to need one double integral for this part, and you're going to need another double integral for this part. So just look inside the blue box there. A horizontal line passing through the region will always have the same right and left curve. That's a horizontally simple region. A vertical line passing through there is going to change top and bottom several times. Look at the purple box. On that region, a horizontal line passing through the region will always have the same right and left curve. So that's horizontally simple. It's not vertically simple. It's closer to vertically simple, right? Because you start out and initially you have like the parabola and the line. And then when you get to about 8, it looks like you switch from the, what am I even saying? Oh yeah, and then at around 8, you're going to switch from, you're going to switch from the parabola being on top and the line being on the bottom to the parabola being on the top and y equals -4 being on the bottom. It's not vertically simple. So horizontally simple, don't be afraid of horizontally simple regions. People shy away from those. They make your life easier, right? So you always want to be doing like the easiest of the double integrals, because double integrals by themselves aren't necessarily very easy. All right, so that's the idea. I'm going to come back in the next video for page 6, I suppose, and we're going to actually do some of these things. So I will see you there, and I hope this was helpful.